is going to be the mv. So you know you're going to get one velocity here. So if I release one spring, push the object here to smaller mass, I'll get one velocity. Now if I release two springs, then I will get 2 units of velocity. So whatever the velocity is, it'll be twice the velocity.
Okay, so let's test out this claim, shall we? Because the man himself will never lift a damn finger testing out one of his own claims. So, I've got a setup over here. I've got some explanation to do. This is one of my new equipment. This is a pendulum, actually. I've got a bar at the bottom, a mass attached, and then over here we have a spring, but it's the type of spring that you have to pull, right? Not the kind of spring that you have to compress. But I think it's the same principle. So the bottom of the pendulum will go through the timer, and here is the display. So I will pull it always to the same. I will stretch it always the same distance, all right, till this place, and then I will release it, all right, and then we will see the timings each time. And then for our second trial, I will add another identical spring, right, just beneath it, and then I will once again pull it backwards and then release it, and then we will see whether or not, yeah, well, the claim is, so this will be 1 unit of energy, and then the same spring stretched the same amount, 2 units of energy. Will it go twice as fast, or will it be more closer to 1.4 times as fast? What will happen? Let's find out. All right, here we go. One spring, 43, 42, 41, 42, 43, 43, 42, 'That's not good. 42, I think we have consistent results. 44, all right. Okay, so now I have added the second spring underneath it. So let's see what happens. 30, 32, 32, 32, 31, 31, 31, 32. Okay.
So, with one spring, we mostly had timings around 42 and 43. With two springs, we mostly had timings around 31 and 32. That gives us an average ratio of around 1.35.
This is a variation of the same type of experiment, but this time I'm using a rubber band. This is one rubber band, and I'm going to pull back the pendulum, and each time with the same amount of stretch, right? And then let it go. It will go through the timer. We're going to read the timings, and then I'm simply going to add another identical rubber band over here, and I repeat the same experiment and then see what the velocities will be. Okay, so here we go again. What is that? 60? 59? 59? 58? 59? 59? 59, all right, pretty obvious. Right, so now 2 pairs of rubber bands, all right, see? There we go, again. $42, 42, 43, 44, 43, 45, 42, 43, all right, 45, 43, all right, that's it.
With 1 rubber band, we mostly had timings around 58 and 59. With 2 rubber bands, we mostly had timings around 42 and 43. That gives us an average ratio of around 1.37. Conclusion: with springs, we had a ratio of 1.35. With rubber bands, we had ratio of 1.37. Both ratios are significantly closer to 1.4 times as fast than to 2 times as fast. Is this yet another coincidence? Another forced experiment? Another crappy junk experiment that just happened to match conventional science pretty closely? Why is it that we never get close to Draft Shit's predictions?